Hello, everyone. Welcome to a series of talks about AI technology and investing. And let's take it forward. Guna and Kiran are with me, and we'll discuss about news that you know broached the topic of AI this week around the world.
Yeah, so I'll share my screen.
Yeah.
Yeah, sure.
Okay, so for week three, we have pretty interesting topics. Again, NVIDIA and OpenAI is there, but apart from that, we have some topics on the government as well, the US government. So these are what we're trying to cover this week. So this is NVIDIA's project digits, and this is also NVIDIA's Cosmos, and there's Apple lawsuit, and something that Musk had to say, and that's a and Biden's plan on chips export. So, so the first things first. So NVIDIA they released this thing called Project Digits. So what it is basically the world's smallest AI supercomputer. Then aiming it to be the smallest. So yeah. So when you look at it, this is how it looks. It has the GB10 super chip Blackwell GPU. And coming to the performance, they say that it can perform 1 quadrillion calculations per second or 1 petaflop of AI performance. So to give a context of what 1 petaflop is, so imagine if we're trying to solve a really hard math problem, and if you could solve that math problem in 1 second, do 1 petaflop of that, it would take you, I think, around 30 million years. And that is what this thing can do in 1 second. So to get a scale of what it is, yeah. And it is available. Right now it's on waitlist or something like that. It will cost around $3,000. And the more interesting part about this is you can combine two of these together.
So did you say 30 years or 30? How many did you say?
30 million years.
30
That's
million
what.
years. So
Yes.
what kind of computation is this?
So so they are telling it's an AI calculation, like a really hard math problem. Suppose you're multiplying like really large, very large numbers. And if you could do that in 1 second, it would take you like 30 million years to do one quadrillion calculations. And
I
that
mean,
this
this
thing,
this might not be known. Well, what is a quadrillion? Is it like one followed by 15 zeros? Trillion is tri billion is 9, trillion is 12. Quadrillion. I think you have to
it's one for one to
One
the power
quarter.
of
Yeah.
my God, one followed by 15 zeros.
15 zeros. So after trillion, trillion is like, yeah, okay,
Yep. So it
quadrillion.
comes out.
Cool. So, I mean, what are the use cases? I mean, this is $3,000, and is this part of the NVIDIA conference that is going on? That's where
Yeah,
this
Yes.
news.
CES last week is one.
Oh, that looks nice. It looks like, I mean, just as a general comment, looks like a breakdown of a camera, old
Mhm.
school camera,
Yeah,
but
and you can plug it into the wall. It runs on like a normal wire. You don't have to use anything special for it.
okay.
And they
This
have their own software and platform where you can develop stuff and all that.
and did anyone give a talk on this
Oh
particular?
yeah, yeah.
Actually, there's a video, sir.
You can just we don't want to watch the video, but we just will
Yeah.
just scroll through and see project digits. Oh, okay. So they're trying to promote. That's a 20-second.
As in, you don't need to write.
Oh, but I can't hear anything. But that feature has been enabled. Oh, there is no volume here.
There's no
So there
volume.
is no volume.
There's no volume. Oh, okay.
Yeah. So
It's
this
like
is what.
a supercomputer on your desk.
Yep.
I think they'll keep coming up with new supercomputers. So I think NVIDIA seems like the company to work in, right? Everybody wants to work in NVIDIA. I don't think anybody in another weird anecdote that I heard in NVIDIA, I don't think there's a single employee whose net worth is like under $1 million. they're all locked into some sort of, I mean, million is a small number, but for those guys who are making that kind of money, but pretty much everybody is locked into long-term stock options. And it's like what they call the golden handcuffs. Like once you're in it, you cannot quit, but because there's so much money on the table. So I think a lot of the employees have remained in NVIDIA for a very long time. And I'm assuming that's probably the reason why. Another interesting anecdote about NVIDIA is like, that Jensen quoted in one of the interviews. Their standard H100 product has like 30,000 components from different vendors. I mean, I wouldn't say 30,000 vendors, but 30,000 components from various vendors, and it's fetched from various sources. And the fact that they have sort of mastered this broader uh, access to supply chain ensures that they have a competitive moat in this area. I don't see anybody near that feat. But even though NVIDIA is a chip company, it's still dependent on Taiwan Semiconductor Company, TSMC. And what they do is they build a layer of software and testing on top of, let's say, their underlying chips and make them specific to certain use cases. So they don't make their own chips. I mean, they assemble a bunch of chips and make them work in a certain way. Exactly. I think they're in the same group as Texas Instrument, and even for that matter, Intel. So Texas Instrument, they do the boards. So once they get the chips working. They get them from some vendors in Taiwan, and sometimes they do the chips in-house. But once they get the chips, they work on a specific use case and release certain, let's say, chips to the market. So one of the chips that we worked on was, I mean, I won't name the exact number of the chip, but they have like around 200 or 300 such chips in the market, and they do anything from video processing in an advanced camera to all the things that go in CCTV footage, capturing the CCTV footage, those sensors. So Texas Instrument is an interesting company that wants to compete. I don't know if they want to compete in this space, but it's an interesting segue. So I think this is good. This is great news. I mean, NVIDIA will always be in the news because it's one of the biggest companies in the world.
Yeah.
And
What else?
apart from this, NVIDIA also launched their 5090, 5070 series. So to give a perspective of how better it is than the previous one, so the previous, like the top tier GPU was the 4090, and now with the 50 series, the 5070 offers the same performance as the 4090, but at one third the cost. So if you had to buy the 4090, like let's say a few months ago, it was around $1,500. Now for the same performance in the 50 series, it's like $500. That's really interesting.
So, but like, so from your understanding, I mean, these are things that I would like. I mean, in terms of cost and stuff, I'll understand. If for general audience who might be in, let's say, your category, in terms of, let's say, people who are younger, who are engineers as undergraduates, if a price of a product goes down, is it a good thing or a bad thing in your view? I'm just quizzing you guys just to see how you guys
I
think.
mean, I personally feel it's good. Like, I mean, these are the stuff that you can use in your day-to-day life. I mean, if you're a gamer, obviously, then you'll be more into that. But also, if you're using GPU for, let's say, something else, you're training your models on that, it makes it slightly, easier rather than have to paying a subscription. You have this offline thing that you can use at your expense. So I
You
feel
don't
that's
have to you
better.
don't have to get the collab which costs like
Yeah.
per month so much. So with one investment you can try on all the models you can,
Hmm.
and with billion
But this is
parameters.
like do it yourself philosophy, right? You end up,
Yeah.
but you have like a fixed upfront cost, but if it's like buying a car as opposed to renting it often.
Yeah.
I think another thing that I wanted to say on this matter was like in terms of how do you guys think of cost in general, but I think we'll probably get to that at the end. What other news do we have in the
So
AI?
yeah. Yeah. So the next thing is again, it's NVIDIA. Yeah, so this is the platform NVIDIA Cosmos. So this is a platform where you train agents basically. Like they give you, like if you can see the pictures, they give you a scenario. This is not AI, this is not real. So it gives you a scenario of like a road or something, and you can train your agent in that. For example, if you're training an autonomous vehicle or maybe a robot to do a task, this Cosmos WFMs, they give you like a platform where you can train all of this.
And I
So
think and the key highlights are like it helps you train robots
Robots, yeah,
and
yeah,
AI using synthetic
synthetic
environment.
environments.
Hmm. Okay. Do we have any video on this?
uh, yeah, on the website they do. Let me just
So I think they are getting into areas wherein they're offering custom use cases to eventual users, and it depends on who ends up using these use cases and
Yes.
making things out of it. Awesome information.
yeah. So this is what it is. Like train your robots to do stuff. I don't know if they have a video on that. Yeah, yes. Is the audio like? Are you guys able
The
to?
audio is not being shared actually.
That is
Yeah,
designed,
it is.
that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it. The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
This is quite exciting, and at least into the point of view of how they have. Let's go back to that video. I'll show you. So I think at the end, when they said like you have multiple counterfactuals right at the end where they separate and they come together, that's basically them modeling all the paths that you would take, which the current technology already does, but you're able to do it in a very closed environment. Like for example, like it will when you look at let's say Google Maps, and when you find the shortest path between any two distances, it also gives you alternate paths, right? So what they're trying to tell you is, and it calculates, let's say, the top five paths and it gives you the most optimum path, like with the cheapest cost. Now, what they're essentially saying is it will do that in an indoor space and it will give you corresponding path as well. So wherein like it's wherein if the optimal path is not captured by cost alone, you can decide and take a second best path, and that would probably help you parallelize few tasks and things like that. But it's all happening indoors as opposed to Google Maps, which is outdoor map data, as opposed to indoors. This is like your own maps. You have to build your own maps of your internal structure. So that is sort of like a neat project. But this assumes that you're integrated with the camera. This is not just a sensor that is moving around. It's a sensor that is moving around while the camera is sort of monitoring the whole thing. Yeah, it's sort of interesting. I mean, I don't know if this is possible, but another thing, that was sort of interesting because that's new. People haven't done that. I've looked at these use cases wherein coordination between two different objects, they were only done in federated learning, let's say in distributed learning settings, but whether they can share information across let's say machines and then they can have collective intelligence, those things haven't been implemented anywhere in a use case which is like custom made. So if you go back right in the middle
Somewhere.
these are fine. I mean, yeah, this is fine. I mean, autoregressive models, I mean, these are things that we looked at in class as well. Like, the output of the second model feeds into the input of the third model. So that structure is autoregressive and diffusion. These two are the models which are prominently used. And what they're doing is customizing it for those specific functions. So you're building smaller, let's say, hardware which customizes to the software that you're running. I think I saw one more use case. Can you play it again? Like some from here? Slightly. Yeah.
It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers,
Move forward a bit.
and an NVIDIA CUDA. World states as videos.
Somewhere here.
Robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA.
Yeah, just hold on. Like what I was talking to you about was where they have an image wherein there are multiple videos and you're able to analyze the multiple videos and collate all of them and have a collective intelligence. I think there's one use case like that. That is new because I don't think people have done that. Yeah, something like here. Or slightly before.
This one?
Yeah, just play it.
Or to test and validate model performance. Even across multi-sensor views.
This one. Yeah, this specific use
Cosmos.
case. I don't think people have ever done this before, at least implemented, but they do it sort of manually, but people haven't. I mean, I'm not sure. Like at least publicly available data, you usually don't have coordinated view. What happens when you watch a movie? There are like different views. The camera looking at it from east, and another camera looking at it from the west, another from the south, or something like that, right? But you get a coordinated view with all by syncing or shifting sequentially shifting between these cameras. But now what they're saying is they can go across cameras and find you the best view, and it can decide on its own in an autonomous way. I think that's what I sense. And I think those are at least not publicly available. They might be implemented somewhere, but it's not publicly available. So that's pretty cool.
Yeah.
You can just play it,
Views.
You can keep it on.
Multiverse simulation to AI
this one.
models, generating every.
Are there any other videos that they have released?
Oh no, this is like yeah, 2 days before. So
Okay. And
So-
is this
yeah, yes.
is this on their own channel, or is this like somebody else did it?
This is their own thing, but someone else has posted it. This guy has posted.
Oh, okay.
Thing. as well. Yeah, so it's the same video, just as guys posted.
Okay, that's pretty cool.
So I
And
had one question, like with respect to like autonomous driving and all that. So like right now in the market, there's like two ways they achieve autonomous driving. So one thing is that they, for example, Tesla doesn't use any sensors; they just use cameras. So they have somewhat like I guess a car is into that scenario in different angles. But there's also Waymo, which uses cameras and sensors and a whole lot of bunch of things. So what do you think is better?
no,
Like,
I don't think it's either or. Everything. When you say sensor, what do you mean? Like, see, camera itself is one sensor, right? It's a sensor-based camera. So that is one. When you say other sensors, they might even be using this technology called radar or lidar, one of
yeah,
these. So lidar essentially tells you apart from the visual, it can also send out a signal called chirp signal. Chirp signal is a continuous. Why don't you Google chirp signal? CHIRP signal. Yeah. So it's like a continuous wave that you hit at some frequency and it hits the body and gets a reflection back. From the reflected signal, you're able to estimate how far the object is from any given point in time. And you collate this information with the image that you have and you ensure that there is no discrepancy between the two. That's what I think Tesla did this long time back, and we used a sensor in our own company on the exact same technology. But Tesla just dropped this completely. They said like cameras are way too better. You can probably have like multiple cameras as opposed to
yeah.
testing it with better. But I'm not sure what Waymo is into because I don't know enough information about how their technology works. But this is how this works. So this is just radio frequency wave, and the simple logic is higher the frequency, smaller the wavelength. So that means if you want to, discern between very small points, that means you need a very high frequency wavelength, something in the neighborhood of 50 gigahertz or 70 gigahertz will even give you small. So 1 upon 70 gigahertz is like the wavelength. So millimeter wave, as they say, millimeter wave technologies. So you can also Google this while you're sharing. Millimeter wave. Millimeter wave lab, you can say. And there are quite a few labs, technology labs. Yeah, just Google it. Yeah, there are lots of companies in various countries working on this kind of technology. All of them work on some version of this. So just to give you some sense of how since you mentioned sensor, this is my field. So at least let's say this is where we built our company. And when we think of 5G, it's all, let's say, broadcasting that happens at 30 gigahertz and thereabouts. Okay, 30 hertz. You can share the screen. I mean, you don't need, but this is also fine. So you have 30 gigahertz, and that's like 5G. Anything above that will also be considered 5G, but your regular phone is around that neighborhood, 30 gigahertz. So that means it can, the frequency, the amount of time it vibrates is 30 gigahertz. I mean, 30 million 30 billion per second, something like that. So, but if you say about 70 or 80 is where a lot of the healthcare companies use these radar-based sensors to essentially get heartbeat, respiratory rate, gait analysis of an individual. These things are all possible at 80 gigahertz. Now, the question is, all these are available. Anyone can build it. You don't need license to use this frequency. But the question is, are there genuine use cases wherein this kind of frequency is useful? And those are things that are still getting worked. Recently saw, I mean, like a few months ago, I saw IIT Madras test out a uh, 6G bandwidth, and I don't know. I think it's millimeter wave. IIT Madras, just type Yeah, test bed. Yeah, this one. This happened, yeah, October 15th. Yeah, I saw some post on that. You can click that, I think third one. Does IIT Madras have,
I'm looking for the
okay, you can
issue.
probably click that.
Yeah, yes.
So
This
this
is
was in
the
the news sometime around October, and I saw some demos that were posted on LinkedIn, and few of the people I know, or like I
Mhm.
know their friends from whom they posted on LinkedIn, and that's how I got to know. So these are all interesting technologies. The question is, are they enough use cases? When the technology gets introduced, the time somebody uses this technology and builds a product that will probably take 5, 10 years, and how quickly all these converge, nobody really knows. So
so
millimeter
when
wave,
you I just had one question. So like let's say now we are using 5G, right? So if there is a shift to like let's say 6G, what kind of infrastructure cost or upfront cost would it take? Like do you have to like use other hardware or is it just does it work on the same towers and stuff like that?
I see. I think there is a lot of backbone infrastructure, obviously, that the consumer doesn't have to pay, but the companies have to pay. The companies who are working on these kinds of things. I don't know enough about 5G to a point. I mean, even though I know more things about 4G and 5G, but I don't know enough things about 6G at all. But there's a lot of cost in terms of, let's say, people building the backbone, right? So usually, millimeter wave test hub or 6G test hub is what that's the keyword. If you search on that, you'll get enough labs around the world working on some sort of a broadcaster or some sort of a hub that they build that broadcasts all these signals. You can probably take a look at these, but I don't know enough. I haven't kept up with all the research that is happening in that field. But I'm pretty sure these things are there. But if they can find use cases, can you think
Mhm.
of any use case? Just type 6G. Wait, I even know.
Machine learning.
We can
Collaborative
probably come back to that. Why don't you? I mean, I can't remember the exact name. There was one company which was working on this, not like 5G testbed. They were doing something else and sending satellites up in the air, something like what SpaceX does, but India-based company. But I'm not sure what they are doing now. I even forgot their name. It had a weird name. But we
Okay.
can take a look at it. Do you have other points that you want to run through?
Yeah. Yeah. So this is one of the most interesting things, I believe. I mean, this is not new. This lawsuit was from 2019. Only the results of it were like a few days back. So I thought it would be interesting. So yeah. So what basically was apparently in 2019 they found out Siri was eavesdropping. So basically you didn't have to say hey Siri or something like that. It would still be listening to you. And what I felt interesting was the payout. So Apple has agreed to pay 95 million to users. That amounts to around $20 per person per
Per person,
device.
yeah, 1700 rupees per person.
So I find it funny that the
How
cost
much
of
money
your
did you say? 17,
1700 rupees per person, sir, in India.
yeah
For this
per
thing, what's
person
this?
seventeen hundred
per person.
dollars?
1700 rupees,
No, so $20 per person is
$20
what
per
they're paying
person
out per person per device,
per
and the cap
device.
is 5 devices.
As this has happened, Apple for the pay for to make the tub, the Apple has paid 1700 rupees per person in India. So like
How in India alone or any other country?
in India alone, as far as I know, sir.
It's
Okay.
like I don't think it's in India, it's in USA because
It's
it
in
was
US.
like $20.
Even in India, it has
And
happened,
yeah,
as far as I know. Yeah.
I think there are no regulations in India wherein you can take a
yeah.
technology company to court. All those things don't happen.
Okay.
So usually, I've never seen a civil, let's say, civil court in India take a technology company to task, wherein like you can somebody can file a litigation that goes to court, and the courts get to a judgment wherein they've actually awarded compensation for, let's say, noticeable harm done to some customer or some employee or anything of those. So those cases never, at least are in the news, or at least they never have compensation, which are like what is called punitive, which means like it's not measurable totally on the extent to which the crime has been committed, or let's say the the damage has been done. It's dependent on the amount of net worth that you have. So especially I was using, somebody used the word punitive damages for with your other story, Sam Altman's story. And when punitive damages means it's not related to the amount of damage that's been done. When crimes such as those are involved, it's totally dependent on the net worth of the person. So instead of him paying out, let's say 5 million, they might ask him to forfeit, let's say 70% of his net worth entirely, if that is true. But I don't know, it will, again, these things are settled outside the court. So
I
we
think
can
this is
probably go
interesting.
to the
Yeah,
next story. Yeah.
sorry.
So this happened. Yeah, we can. There are no sources or anything like that. But let's suppose we'll probably put some links or something later.
Mhm. So I think this is also interesting, like, because the way consumer courts work here and in India, it's very different. So I think people take it a lot more seriously. Litigations are taken more seriously here than in India. And we've seen
Oh,
more.
you're saying litigation is taken seriously in the US? That's what you mean?
Yeah, like a lot of
Oh, it's
people
this
suing
is the
stuff.
most litigious society in the whole world. I mean, but which also benefits as a result. Why is there all the, if you look at all the, let's say, capital around the world comes to US to invest. Why? Because the legal system has withstood the pressure of time for like almost couple of centuries, more than a couple of centuries, to a point where they have enough credibility wherein anybody from an unknown country puts money, they still have rights. Those rights are protected. And that's why every company, every startup starts their company, start their company as a Delaware C Corp. The reason all startups start as a Delaware C Corp is even somebody who, so it's very shareholder friendly. That means even if you own 10 shares in a company, you can stop a board proceeding from happening. This happened in Tesla, wherein somebody who there was compensation announced for Elon Musk for 50 billion, and somebody who owns 10 shares in Tesla was able to file a case saying that the compensation was disproportionate to a point wherein it harms the current shareholders. Like if you allocate new shares in a company and give it to one person, then the value of the shares held by the previous shareholders decreases in value, at least not in immediate dollar terms, but overall effective shareholding sort of dilutes because you're creating new shares and you're giving it to one person. So they said that this is not possible. The counter argument to that was the entire company is dependent on one person, and this one person is very important, and he hasn't taken salary for 10 years. So you might as well give him something that is commensurate to the value that he adds. But he was able to stop it, and Tesla couldn't even go ahead with it. So they had to reincorporate as a different company altogether in Texas and redo this whole process. So even if you own, let's say, 5 shares, you have tremendous rights about a company as big as Tesla. That's
So
why I think
are these rights state specific or like it's general
they are
for
state specific. Yes, they are state specific. Delaware has the best corporate protections for shareholders. The next is Wyoming. So all, let's say, corporations who are from different countries like Spain, India, China, they all want to incorporate in Delaware or Wyoming. Delaware is like there's almost like 80% market share in terms of incorporation. You can incorporate in Cambridge or Boston too, but it doesn't have the same amount of protection that Delaware has, even though it's like nearby states, same culture, all that. It's just it's a matter of precedence, and because they have state-wise precedence for a long period of time, and they maintain that reputation around the world, they are able to attract capital. It's state specific. All rules are state specific, including, let's say, gambling, for example. It was legalized in few states, and now it's legal in 39 states. As a result, the big gambling companies like DraftKings and FanDuel, these are the biggest companies, which were sort of not even legal before 2018. Now they are legal, and they probably do like $50 billion worth of revenue now. So it's all state specific. But
So yeah,
just so that you know, even though if you're an international student, you might think like, let's say, in a state like Massachusetts, marijuana is legal, but you as an international student still cannot access that. If you get caught doing that, you can be deported still, because the laws that protect immigrants are usually federal laws. Federally, marijuana is still illegal.
oh, okay.
A lot of people don't know this. They might get into trouble if they just violate, or if they get caught using it. So you might think like the law applies uniformly to citizens and immigrants. It's not the case at all. For an immigrant, the laws that govern are state laws, but broadly, the reason you are there in any given country is sanctioned by federal government, and federal government, it's illegal still. So if you do a immigrant check, for example, if you're on the final process of green card, if you do the immigrant check and they discover that you've been, taking a lot of, I'm not sure about, I'm a bit hazy about it, but they specifically say if you taken a lot of drugs and then that shows up in the report, that might create issues. So even though the equal law applies to everybody, the law that governs immigrants and the law that governs, let's say, permanent residents and citizens are different state-wise. So you have to be a little careful on those. Yeah, I mean, but
So I find it interesting that companies have marijuana drug tests even though it's legal. I don't quite understand why that is.
can you repeat that again?
So yeah, like this is what I've heard from a lot of my friends. So they say that before you go to a co-op or something, some companies do require you to take a drug test, and if you're found using marijuana or something, they don't usually hire you or they blacklist you.
Yeah, they can do that because their companies are incorporated in states where that is illegal still. So they can totally, best is to, if somebody is asking for it, see, if I conduct a math test, I'm hoping you'll be good at math tests. Otherwise, there's no point in, if somebody is conducting any tests, you want to come out as on the positive side of the test, regardless of the law, right? If somebody is, conducting a vocabulary test, he's hoping that some people are good in vocabulary. That's why he wants to separate them from other people. What's the point of doing a vocabulary test otherwise? So yeah, that is true. It's totally true. So just be on the safe side. Are there other?
Also, reverting back to that betting thing, I think I was in Las Vegas a few weeks back. The betting
Oh, you were in
industry,
Las Vegas. So what did you do in Las Vegas?
I visited every casino that there is. I didn't gamble. I don't know how to gamble. It looks like a game. It doesn't feel like you're gambling, to be honest. It feels like it's like a arcade, a bowling arcade, to be honest. It's just that you're putting real money into that. And one of
Mm-hmm.
the interesting things that I found out was like when you go into a casino, you don't really know what time it is. You're completely isolated. So there's like restaurants, there's shopping malls, there's like Gucci showrooms in each casino. So once you go in, you won't know like if it's day or night. It's the same entire thing.
I think it's open 24/7, right?
Yeah, yeah. Also, there's also all these buildings have this thing where they promote online betting. I think this is more common in India, but what I'm seeing is even in US, I'm getting more ads for like betting apps and all of that, BetMGM, where all these NBA players, they promote this betting.
FanDuel and DraftKings. See, I think honestly speaking, this is one of the most. I'll tell you something about FanDuel and DraftKings recently. They look for, they don't want people who bet well to play the game. They're specifically looking for people who are bad at betting to be in the game and lose the money. The house always wins, okay? The best probability, I wouldn't say best probability theories work in these companies, but I'm pretty sure a very good data scientist or a machine learning person is designing all these schemes. And FanDuel and DraftKings specifically look for candidates who are very weak and are isolated on their own so that they have this dopamine hit every time they gamble and they just want to chase that dopamine hit every time. And if you're reasonably good at, let's say, basketball, and if you want to bet on basketball bets, or sports betting is legal. I mean, if they should legalize this in India, and people would love to bet on cricket every day. And the amount of chaos that it created, even when it is illegal in 90s and early 2000s, was bad enough. But if they legalize it, it will be great business. I mean, uh, it would be great business for cricket and administration, wherein they can collect taxes off it and all that. But I don't think they'll ever legalize it because there are enough vulnerable people on the margins of society who will completely bankrupt themselves. The states that have legalized betting, the bankruptcies have gone through the roof in those states. Most bankruptcies are single men betting their hard-earned saving, hoping that they'll go to the top. I think on this topic, Squid Game 2 was released. And I mean, the whole story of Squid Game 2 is essentially the idea that people are in debt and they're desperate and they take chances. I'm still watching it. I don't want any spoilers. I'm still in like
I completed
fourth
it.
episode of season 2, fourth or fifth episode, wherein they choose after the first game whether they are collectively supposed to leave, and they are assuming that everybody will leave, and then they realize, oh, what's the point of going back? We might as well win everything, right? That instinct of gambling. So if you study probability theory and if you take my, let's say, take my class or whatever, you should never gamble on anything. But find out information and bet on good things that any bet is a sure shot bet. The most people think like entrepreneurs are people who take risk. I think entrepreneurs are people who avoid risk at all circumstances, and they figure out where the risky things are and where the you know things are not risky, and they figure out ways by which they can return money without any risk. So what is a good entrepreneur? A good entrepreneur is the guy who takes capital, allocates it, gets a return, and he becomes like a machine wherein you take money, allocate it, put it to good use, get revenue out of it, and return the money. And if you're betting, or if there is any hint of uncertainty, then you should collect a lot of information on it. And it's a very dangerous thing. I hope, like,
I can wrap you.
if you ask any serious economist, somebody like Paul Krugman, whom I respect a lot, or Daron Acemoglu, the guy who won the Nobel Prize this year, like any serious economist would think this is like a public health problem. It's not even like a social issue. It's like a public health issue because people will go bankrupt. They'll lose their minds. A lot of people will be depressed. It's a public health issue. So ideally, it should not have been legalized, but we're in Trump era, so everything is legal now.
So one more interesting thing about all these casinos and betting apps, they give you a sense of false security. So with my case example, so when I checked into the casino, like I was staying at the casino, so they give you coupons, like per person, they give you like $200 of coupons, and they ask you to go and bet. And they tell you if you bet this much, you get a free meal or something like that. This is also
Yeah.
prevalent in these apps like BetMGM or something. They tell you like the first bet that you do up to $1,500 or something, you get half of it back if you lose. So it's like they're giving you a sense of false security, and also they're kind of rewarding you in a small way to spend your money.
Yeah, I would say if you're into poker and if you want to learn that game, Go ahead and learn it. It's a fantastic game. It will help you think probabilistically on lots of different things, how to gather information, how to look at another person and discern information from that. It's all great. I think what's the movie from Matt Damon and Edward Norton? I forgot. It's in the 1998. They made a great movie on poker. It's a great movie, must watch for people in property. I think you even introduced it somewhere. But on a general note, I mean, you should figure out if you can really find out some information that other people don't. Only then it makes sense. Otherwise, no point in betting. Matt Damon, Edward Norton poker game. Yeah, this one, right? Yes. Fantastic. I mean, John Malkovich in this. Yeah, this guy is phenomenal in this movie. I mean, he's the villain in the movie. The way he has acted is quite astonishing. And Edward Norton in every movie is great. Edward Norton is doing a startup now. He's doing, I mean, he's a phenomenal actor too. But you should, it's a must-watch movie if you're into probability and stuff.
Okay.
Oh, by the way, Matt Damon grew up in Central Station. You guys know that, right?
No, we didn't know that.
Central Square. Yeah, what am I saying? Central Square. So he said that in one of the, yeah, he's a local product. Oh, by the way, there are a lot of local products. Matt LeBlanc from Friends.
Yeah.
Joey from Friends. Yeah, he's from this place, and he was, I think, classmates with the comedian. Who's the comedian? Oh, I totally forgot. He was classmates with one of the comedians.
Okay.
Yeah, they're from Newton, the Green Line, Newton. Yeah, they're Newton school. I think all the best schools are in Newton. So the way this Boston school system works, there are like lots of primary schools. There are only like two big high schools, and one of the big high schools is in Newton. Ian Caroline Ellison, the lady behind SPF, they went to Newton. Anyway, are there any other news?
Yeah, we have like two smaller topics. So this is what Elon Musk has to say. Like this is a few days old. So he's like, there's a need for synthetic data. I mean, this need has been there since a long time, but he's telling that. I mean, there are also studies that say that by 2030 or 2032, there'll be like a desperate need for synthetic data if you want to better your AI models.
So that's why he tweets false news all day so that he creates synthetic data. But anyway, I'm just making fun of him. But I mean, he's not going to listen to us anyway. But the point is, I mean, what he says is, so the way to think about it probabilistically is the map of the world is all the events that happen, right? So you assume that somebody who is in high school tries to get to college. So you only have data of the person who was good in high school, got into college. But what about the other data of the people who dropped off the study, right? Who went to high school but didn't go to college? What happens to their lives, right? Nobody looks at that kind of data. Synthetic data is always think of the counterfactual of the event. There's the idea of probability is an event happens, and from that event there is information. But there is information in the counterfactual too. When the event doesn't happen, the alternative of the event, let's say you have head and tail, and the head happens with certain probability, the tail happens with certain probability, but we always assume the event probability. What about the non-event probability? That's essentially synthetic data. But I'm assuming that's important because it helps you understand. And if you can get precise fraction on this, it helps you compute probabilities properly. And that helps you in modeling and all those issues.
Yeah. So
I mean, he's right on that point, but I mean, he's also spreading a lot of fake news of late. But I think his strategy is basically to go to every country and get the people in the 10th percentile, or let's say the 90th percentile, people who are on the fringes of society, to talk to each other. Because people on the fringes of society make the most news and they bring the most engagement. If they get more engagement, they get more ad revenue. That's his business model. But I think that's a very bizarre business model, but I think it will totally work. That's why Twitter was never profitable. It still is still not profitable. Probably it will become profitable, at least by the way he's executing things. What's the next one?
Yeah, so this is also one of the studies that says that, pretty much just this paper says that by 2030 or 2040, we'll run out of real data to train our models. Yeah, it says here. Yeah,
I think
2020.
he's talking about real text data. I think there'll be
Hmm.
new data, stock of public human text data. Yeah, probably, but we will probably generate more text data by that time. Is this? And what did they say? We argue that synthetic data generation, transfer learning from data-rich domains, and data efficiency improvements might support further progress. Sure. Okay, can you open the PDF? Very curious. Like, are there any models? The PDF on the right top corner. Just scroll down quickly. I don't have to read. Like, I just want to see if there is any model or anything. Just stop at the model. What are they saying? Just hold on. Just hold on. Yeah. They're just on top. I'm looking, when I say model, I'm looking at the equation. Okay. What is the math that they're using? TD is the factor growth per year. What is it like? Okay. You can scroll. Yeah. Compute based data size growth projection. Yeah, mixture projection. Size. Okay. You can scroll down.
This is long. It's 22 pages.
Wait,
Okay,
22 pages is long.
I mean, these
Seriously.
are just reference field.
See, I've read papers like probability papers, which are like 200 pages, okay? 200 page, one paper.
But in the
160 page,
retrospect,
one paper.
yeah,
Yeah,
there's
so
a reference. Okay, no, there's no.
22 pages, like, no, nothing, man. There's barely anything there.
Yeah.
Yeah, it's fine.
Okay, so we also built a data center in Memphis. This is very recent. I think it was functional in December. And they built it in just 122 days.
Okay, this facility XAS significant strides. Okay, equipped with 100,000 NVIDIA. Wait, did he say 100,000 NVIDIA H100 GPUs?
Yes.
My God, that's a lot of H100. Those are pretty costly. Those are not like cheap. H100s are not cheap, and it's considered one of the most powerful AI training. NVIDIA H100 cost.
Oh my God.
These are like an 8 cluster. It's like $192,000. Yeah. I think the actual cost of this to manufacture it is probably like $1,000, $500, $1,000. All that is profit for them. But they've figured out how to extract so much value.
I
Anyway,
guess most probably the cost is because there's no competition. Does it make sense?
no, there is no competition. They are a single monopoly. There is no competition. A lot of people are trying to replicate NVIDIA, at least for the last 4 years. Nobody has come close. So they're the only company which is making money. So nobody else is even making money. All the software companies are just still losing money, and I mean,
Oh,
they've been in the field for the longest. If you think about it, they're the last classical hardware company, which was founded in 1993. Somebody started a hardware company in 1993, nobody would have funded, because in 90s it was all about internet. 93, 94, 95. It's like the age of internet, and everybody was going towards internet. And this guy still did the hardware company. So if you look at the market capitalization of Nvidia, I'm pretty sure it's been video. A lot of videos exist on this. Up until 2016, every year for the like 10 years from 2005 to 2016, the market capitalization was 10 billion with no movement whatsoever. So if you look at, let's say, max, you go for the max market cap. So it's like, see, from 2005 to 2016, it's almost like it didn't move. It was 10 billion. And now it's like, can't even believe.
3.4 trillion. Is what they
Yeah.
say.
And all this is in the last, after pandemic, it's
Yeah.
been huge.
So one more interesting thing about this H100 is, when we move on to the next, I'll just show it there. So this is what Biden is doing right now. They're tightening exports to specifically China and Russia. And
Oh,
NVIDIA H100 is one of the affected ones.
oh, okay.
Sorry, this is,
So they have to figure out a way to get H100s in some other way.
yeah.
Oh, okay. That's sort of interesting. Just hold
So,
on. So you can go ahead.
yeah, so these are all, so AMD is, I'm not sure, I think it's the MI250 chip, Super Instinct chip, and the MI300 Instinct chip. They have a travel ban. So if I can just a minute.
Oh, you're sharing something?
Yeah, yeah. So this is the MI250 chip, and the below that is the AMD 300 Instinct chip. So these four chips are what they say is mainly affected. So how they are restricting it is like they have put three tiers of restriction. That's like mild, medium, and high. So some chips they don't want to export it to any country like China and Russia. That's what they're telling. I think I have a few notes on that.
Oh, okay. I mean, these kinds of restrictions they are trying to put in, hoping they will get some control over it because the biggest fear that they have is not even a technology fear that China will overtake US supremacy in AI. The biggest fear is they might, China might attack Taiwan any at any point, and the biggest problem apart from democracy in Taiwan, the biggest problem is TSMC, which makes 90% of the chips, is located in Taiwan. And if that stops, I think the whole world will come to a, standstill, at least not completely, but at least briefly. So one of the
So
news articles I sent, probably once you're done with all yours, I'll probably say something about that. A very interesting trade.
so when you say attack China, what do you mean? Like
No, no,
attacking?
China attacks Taiwan and takes over Taiwan.
Yeah, I
Then
meant like a physical attack or like they just overthrow the government or something like or like straight on
I,
war.
I, I think all options are open, and they're doing military drills in China regularly to take it by force if the need be. So the actual mandate was they will get a government in Taiwan, which will eventually acclimatize to China anyway. So the opposition in Taiwan wants Taiwan to be part of China, but the ruling party doesn't want, they want to maintain themselves as a democracy. And they look at what happened to Hong Kong. Hong Kong was a British colony up until 97, and they became independent in 97. With the contract with China saying that for the 50 years from 97 to 2047, they'll be an independent democracy. And once after 2047, they'll become part of China because they want some time to go from the British democratic system to, let's say, the Chinese communist rule. So, but there are crackdowns right now instigated by China, hoping that Hong Kong they didn't honor the 50-year contract. So this particular government is little aggressive. Aggressive is the nice word to use in terms of their actions. They're a little aggressive, which makes everybody else tense. The economy gets tense because people are worried about chips. This might again cause what happened right after COVID, wherein there'll be a chip shortage in everything, and chips are there everywhere. So it's a very dangerous scenario.
Yeah, so I'll just come back to this restrictions part. So yeah, so it says that they're gonna give full access and they're gonna allow exports to countries such as Japan, Europe, and Australia, and limited access to countries in the Middle East, and virtually no access to some of these chips. These chips that in the virtually no access tier are this AMD's MI250 and MI300 accelerators and NVIDIA's A100 and H100 GPUs. So they don't want to export any of these. They don't want NVIDIA to export any of this to China and Russia.
Interesting.
And the official reason that they give is that they want USA to have a technological edge and also stating security concerns. That's what the government, the Biden administration is saying.
Oh, that's an interesting point of view. So I think the person who you should probably take a look at is there's a guy by the name Jake Sullivan, who's like the NSA of Biden government. I mean, Jake Sullivan, yeah, NSA. So he had him and let's say anybody related to those people. This comes under Secretary of State, whoever is Secretary of State, like Anthony Blinken, their department handles all these. So I don't know how it will change once Marco Rubio is the new designate, Secretary of State. So he's like a moderate person, but you never know. Marco Rubio, right? Oh yeah. He ran for president in 2016. He's pretty young, 1971. So he probably wants to become president himself someday. Yeah. But I don't know how much I mean, he's a big, big R Republican, as they say. Strong Republican. Can we go to the
Yeah, that's it for this week. That's it from me.
So I think I sent you one link. No, let's if you can open that link in some way.
Yeah, let's check it out.
So there is this company, just to give some background, there was this company called Cassava Sciences. So they have this product called Simufilm. And that's their drug that they're trying to get to the market. If you open another tab and open Cassava Sciences, Biosciences stock price.
Okay.
So look for last 6 months. So what happened in the month of this report was written in the month of November, and the person who has written this report is very famous in pharma industry. By the way, Vivek Ramaswamy also invested in Martin Shkreli's company, and they both were famous in mid 2015s. So this is what is called a short selling report. So if some company is doing some nefarious activity, and if you want to voice that opinion and also profit from it, so you can get into a short position with that company, not with that company, let's say with an exchange, you can buy a lot of put options wherein you benefit with the drop of the stock price. So what Martin Shkreli did is release this report. And I don't know if this really, the release of this report allowed that stock price to drop down 98%, but it went from $22 to $2. So if he had invested, I'm assuming he must have invested in this stock, in this short selling, he probably would have benefited, at least would have made like 10 to $100 million on that one trade. And the interesting thing about this report is it also tells you one thing about Alzheimer's disease, one of the hardest diseases to cure. Vivek Ramaswamy's company, Exovent, also had a drug which didn't go through. Almost 98% of all drugs which are trying to tackle this disease fail because it's a very hard disease to tackle. I mean, there are a lot of problems in terms of structure and stuff. So I'll probably take this up in one of the classes and figure out how this works, because it tells you a bunch of things about proteins, a bunch of things about pharma, and a bunch of things about statistics, which are important. So I'll just quickly, if you can scroll through that report, you have to, on the left, you have to scroll through. So I won't get into all the details and stuff, but you can just scroll through. We'll just look at some diagrams. No.
Okay.
Yeah, you can go quickly. So I've read this report in detail. No, not this quickly. So these are like the founders of the company who had invested in it. So you can scroll down even further. So Yeah, not this one there. I mean, I won't be able to comment on any of these. Oh, okay, just hold on. Those tables. Yeah. So what they essentially tells you is, so they give what is called they run what is called a trial. In that trial, they take a bunch of patients and they give some sort of a placebo drug, and they give the actual drug to a few other patients. And the drug has to, the case and control. The control is the placebo, and the case has to statistically exceed the effect of the placebo drug. So if you look at eventually you'll get some sort of p-value at some point here. Is there a p-value somewhere? Okay, these are like differences, but you can see that the placebo is as good as this is. These are like pain intensity scores. So the lower pain is better, right? So and they measure the pain at 1 week, 12 week, and 12 week from the baseline, right? So you're assuming that if you're on a drug, the values have to go down, right? So placebo, but you can see the actual drug, oxycodone, is not significantly different from placebo. Even in placebo, it goes from 7.7 to 5.2. If you go down, that's placebo. 7.7 to 5.2. No, 7.7 is the mean, and 1.44 is like the standard deviation. Okay. So if you go down, so, right there. So you see at 12 weeks, even placebo also the pain reduces naturally. But oxycodone says that they've got a statistically significant result. So what they essentially did was they conducted a study, and they had like few patients whose pain had not reduced at all. But what they did was they dumped those patients' data and reported only the patients which had like slight decrease, hoping that nobody would notice and they'll get a positive result. Now that is classic fraud. I mean, you can't do that statistically in any study. So before, that's why you have to decide the sample size of any given study before the study. And you cannot take patients away, or you cannot recruit patients based on how you want the result. That is not the right test. So you decide the cases and controls. You decide 50 cases and 50 controls. And then you do and administer the drug, administer the placebo, you note down the values, and you report it as is, whether you like it or not. But these people threw away some of the data and reported it, hoping nobody would notice. And this guy noticed and figured out, hey, this is almost important. And the reason he noticed it was he did something on, I mean, he's very, very famous. He's famous for all the wrong reasons. He went to prison and all that. But apart from that, he's also a genius in terms of finance and pharma. And anything Vivek is famous for, he is just as good, if not better, in this game. But the thing is, he is like a child prodigy who didn't go to college himself. So he just started working in Wall Street at the age of 17, and he became really good in medical chemistry and finance. So if you want to understand how biotech industry works, he's probably the number one guy to go to. And he has like a YouTube channel, and he releases a bunch of reports on a regular basis. He's wealthy himself, but he became very famous in 2016 because he raised the price of one drug almost 600%, and he became famous for all the wrong reasons. But he's a pretty clever guy when it comes to understanding how drugs work. So he has a bunch of videos on YouTube. You guys can check it out. You can go to that report again. So you scroll down further. So this is how you write a very good report, which is carefully, like he has mentioned the timeline of the researcher, what is his achievement, and if you scroll down further. And he provides evidence as to why this drug will work or will not work, no matter what. And he gives all these detailed evidence, including, let's say, the carbon structure of that drug. Cassava never had an in-house medicinal chemist. So yeah. So he's looking at all the red flags of any given company, right? So, and you can scroll down. I mean, I won't take much time. We'll just wrap it up. So he's given protein structure of this amyloid. Is it amyloid? Yeah, I think the amyloid protein. And he says something about the interaction and why it's a very hard drug, a very hard thing to model. I mean, I read it like a few weeks back, and I thought I'll bring it up. I'll probably read it next time and present a better one. So basically, he did all this research and he already had worked on this protein before. So he knew that this is a very almost an impossible drug to make. So what these people were doing were taking the same path that had already failed significantly. And since he had already done this, he knew that these people cannot be telling the truth. There's no way they can be telling the truth because they had to be cheating. And he wrote that report, and people around, I mean, entire Wall Street read that report, and the stock went down 98%. So this is a greatly executed short sell, wherein he profited himself 100 million, and the company lost, let's say, I don't know how much was the. I think the company's net worth was 10 billion. I think it's reduced to less than market cap. Look at market cap at the bottom. Market cap is 135.53 million. Yeah, the market cap must have been about like $1.5 billion or two, and it dropped to about 135 million. It's 135 million because that's the owners of the company who hold the shares and they haven't sold. That's why it dropped to $2. So basically, the long story short, if you understand, let's say, protein interactions, and if you can figure out some basics of statistics, once in a while you'll encounter data that will be interesting and you can engage in good bets which will make money. But I think these are once in a blue moon, once every 2 years, these kinds of things happen. Very rarely that some evidence is so obvious or some fraud is so blatant that people get caught. But it's a good thing to know because it uses some knowledge of protein structure, some knowledge of statistics. So I thought I'll bring it up. So that's
Okay,
it.
so I had one question. So like before he kind of shorted the stock, like when he was like doing the report, does this mean the drug was already in the market, but it was in trials? Okay,
It
so
was
it's
in
in
trials.
trials. Okay.
All drugs and no drugs are released before they do trials, and these trials go on for like 5-10 years.
Mhm. So like let's suppose this guy had catch this, like what would it look like? What would the drug look like? Would it be in the market or the government would find this out? Or how does that
No,
work?
this is not in the market. Oh, another thing that you should understand is even R&D companies which don't make money are publicly listed in the US. There are a lot of biotech companies in the US, like in this city, which are publicly listed with no revenue.
Okay.
But they're listed because people are willing to give money for research, which is not the case in, let's say, in other countries where R&D based companies rarely are publicly listed. Even $100 million drug can be publicly listed in the US. So I think that's where you must have had some issues like whether is the drug already in public, what's the fraud here, things like that. It's still in trial.
Okay.
But you cannot commit fraud even in trial because what is the fraudulent activity? Anytime you're borrowing somebody else's money, and while you're borrowing somebody else's money as part of equity, if you lie about your status of the company, that's a fraud. So you're not supposed to ever publicly say anything that induces other people to give you money where the underlying premise is wrong. So that was the fraudulent activity. Okay, thanks everyone for joining. We'll record all of this and put it up on the channel pretty soon. In the meanwhile, we'll just wrap it up for today. Thanks for joining, and hopefully you can join next week.